Again, thanks everyone for joining us today. It's awesome to see an international crowd, some folks from the US. Super cool to have you guys. To briefly introduce myself, my name's Simmons. I'm one of the product specialists here at Ionic, working closely with our products and services in the enterprise application development space. Damian, you want to introduce yourself?
Yeah, my name is Damian Tarnawsky. I'm a solution architect, one of many here at Ionic. I help out customers and solve technical issues and train people, help out anyone that has issues with anything at all. I also jump on Discord occasionally, help out the community, and do a bit of coding myself. So there you go.
We finally snagged Damian live on a webinar. Usually he's in the comments helping us all out, but it's nice to have him live here today. So thanks, Damian, and he's going to have an awesome demo for you guys in a bit. But yeah, we're super excited to dive into the topic of architecting secure mobile apps with Ionic. But before we do, I just want to go over the agenda really quick. So we'll start out with some common risks that often impact mobile applications, and then we'll jump into some of the mitigation techniques to minimize or prevent the potential impacts of these. We'll then discuss Ionic's Enterprise SDK, and we'll kind of show you how it solves all these problems and how it works with a demo after that. And finally, we'll chat through any of the questions you guys might have had along the way. All right. However, before we dive into the material, I wanted to ask the audience and get some initial feedback from you all. So you saw the title of the webinar, or you read the registration page, maybe some of our social posts. So we wanted to hear what you guys came to learn today. What were you hoping to get out of this presentation? And I'll pause for a moment and see if we have anything in the chat. Nothing yet. Maybe it's slow. Don't be shy. You're using Ionic, just hoping to learn more. Advanced architecture design. Easier to deal with compliance. General information about security. Awesome. Best practices. Great. Cool. So a lot of that stuff we will be talking about today. So glad we're all on the same page. If we don't get to one of the particular topics that you guys are throwing in the chat here, it'll be great for us to review back and see if we can do a future event like this or generate some additional content for you all to make sure we get a lot of these areas covered for you all. So thank you guys for providing that initial feedback for us. It's super helpful. But to ground us for today's presentation, I think it's important to understand what's at stake when it comes to proper mobile app architecture. And to be quite frank, for enterprises, it's a lot of money, right? According to IBM reports, the average cost of a breach in the United States in 2022 is just shy of $9.5 million. And that's the highest of any country. And unfortunately, the use of stolen or compromised credentials remains the most common cause of these data breaches. And it shows up as the primary attack vector for 19% of breaches. And sadly, this remains relatively unchanged from the year prior, where it was 20%. However, authentication and authorization issues aren't the only common attack vectors for software, or more specifically, mobile apps. So where should you be looking within your code base for signs of trouble? And that's luckily where OWASP has stepped in. OWASP is a nonprofit foundation that works to improve the security of software. And they've identified 10 of the most common risks in mobile app development. Things like improperly using security controls that the platform provides, authentication or authorization missteps, allowing bad actors either greater permissions than they originally intended or more permissions, poor code obfuscation, where we're opening the doors for reverse engineering, or leaving hidden features or unnecessary code in the application that could ultimately be exploited. So let's look at a few concrete examples. So if we look at insecure data storage, we've seen in PortPass, a Canadian COVID vaccination passport app. where unfortunately hackers were able to gain access to personal data of users because it stored information unencrypted in plain text. And this unfortunately impacted roughly 650,000 users. An example of insecure communication came with a lot of Android apps. So 13 popular Android apps from Google, where cloud misconfigurations unfortunately opened the doors for easy access to data like people's emails and chats, amongst other things. And then there was an example of insufficient cryptography with the Slack application, where there was a bug found within their shared invite link feature that was found to be using a hashed version of the user's password. And they said that clear text version of the password wasn't made accessible, but they also forced their customers to reset their passwords. So this potential mishandling of passwords obviously made consumers a bit weary. But outside of the more public examples that we just walked through, there's obviously plenty of other apps falling victim to other common issues as well. So we wanted to briefly mention some of the things our solutions architects see quite often. So when they're working with organizations, they often end up seeing them storing their API keys directly within their code, which of course we don't want to do. We also see them keeping their tokens within local storage rather than encrypted elsewhere. Or potentially worse than that is we find them using single long-lived access tokens instead of short-lived access tokens with long-lived refresh tokens. And also there's we find them not taking the time to periodically review and evaluate or upgrade their third-party dependencies, including dependencies of our own software as well, which can ultimately have ill effects on the mobile application security. So, all right, we've heard a ton about like these risks, and truthfully, they pop up probably far more frequently than we'd hope. So what can we do to prevent them? Well, we can perform code reviews, right? No matter the level of engineer, whether they're junior, senior, whichever, people make mistakes, right? So it's always good to have an extra pair of eyes or more that are required to review code before it's merged into the main code base. Of course, we can test, and test again. So performing various testing procedures like static analysis testing, which is comparing code against particular coding rules. We could do dynamic analysis testing, where we're using the app in real time and testing its behavior like an end user. We could do penetration testing, where we're testing against specific vulnerabilities in the network or certain endpoints, or hybrid testing, where we're kind of bouncing around doing all of those different various testing procedures. And then we want to follow best practices, right? In general, it's best to remain educated on industry best practices and do your best to adhere by those. So things like proper input validation mechanisms, where we can't just trust the data that was passed from the front end to the back end. Maybe there was a vulnerability in the API and it's allowing bad data to be passed to the back end. So always performing that second level check and performing validation on the back end as well. And of course, turning to an expert, right? A third-party vendor might be the best source of knowledge for secure coding practices or to ensure your technology is guarded against bad actors. So here at Ionic, we hope to serve as one of your trusted partners when it comes to your mobile app security. And that's why we offer our Enterprise SDK package. It features a variety of security-focused plugins to ensure foundational functionalities like authentication, biometric protections, and secure storage are implemented correctly. It also provides the opportunity for industry-leading support and advisory services where dedicated solutions architects like Damian are on hand to work through code and architecture reviews, security best practices, amongst other things. And the best part is that it's all backed by a guaranteed service level agreement. So let's take a closer look at our authentication solution, AuthConnect. So this allows you to drop in single sign-on incredibly fast into your application. Provides a single API that makes it simple to complete regular authentication workflows, things like log in, log out, getting and refreshing tokens, checking the auth status, amongst other things. And with the latest release of AuthConnect 4 in March, not only are some of the major providers still explicitly supported, but the APIs have been improved to provide broader compatibility with additional providers through your own custom configurations as well. And it comes with all the necessities like using native system components, and shared cookie storage. So those are no longer issues that you guys have to worry about on your end. And then for identity management, we have Identity Vault. And this comes out of the box with biometric authentication, secure token storage features. Again, simply drop it in, provide users with the added protections of background obfuscation when the app is in the task manager state, or clearing tokens when biometrics change. And this pairs perfectly with our Auth Connect solution to be able to safely store your session tokens that we talked about earlier. And for secure and reliable data storage, we have the secure storage solution. It's built perfectly for applications that are dealing with larger volumes of data. Think data-driven apps or files that need to be encrypted. It's based on SQLite and leverages that under the hood. So you're getting full query support. And it's also built using 256-bit AES encryption to ensure that your apps have the added protections that they need. And it works in the browser with our custom driver. And this is awesome for web apps or progressive web apps. So you don't miss out on the encryption component. You do miss out on the encryption component in the browser, but of course we have it available in mobile. So it's truly the perfect cross-platform solution to securely store the data that you need in your app. And then finally, when it comes to generalized application security, we offer our mobile experts for their support to your team. So they can work with you in each phase of your mobile development lifecycle, whether that's coming up with development strategies, general troubleshooting and guidance, walking through the code and overall architecture, or providing their knowledge on areas of improvement for your security and performance. So quickly turning focus back to those top 10 mobile risks identified by OWASP, you can see how Ionic's Enterprise SDK assists in protecting against the majority of these, right? By correctly utilizing platform security controls, simplifying those authentication workflows, making sure we have proper encryption and secure data storage, as well as providing organizations with quick and easy mechanisms for safeguarding their users and their data. But of course, it's one thing to say all this, right? And it's another thing to show you how it all works. So we're going to pass it off to Damian to run through the Enterprise SDK in action. So over to you, Damian.
Awesome. All right. What I'm going to show you guys and gals, just jump over to my screen here, is a simple conference application that I've written. And I'm going to show you through some of the sort of common things that you'll need to do with authentication. So sign up a user, sign in, forgotten password, making sure that a password manager works with it, make sure you refresh a token, securely store that token. We're also going to protect it to make sure that when you resume the application after it being in the background, that it's going to double check that you are the user that you say you are. And we'll show some sign out as well. Now, I wanted to show you this live. So as long as the demo gods are happy with me, I'm going to show this in source code with VS Code. And we'll see how this runs. First up, let's just run this application. And while this is building, I've got my my old iPhone sitting next to me. It's going to take a little time to build this app. And we're going to show what we've done in the application. This application has got Auth Connect, it's got Identity Vault, and we've got secure storage in, which I'll talk a little bit about later. So first up, we want to be able to show an unauthenticated page and be able to sign in or sign up. And in your application, you'll effectively want to have a sort of single sign-on solution where you're entering, say, username and password. For this one, I'm just going to hit sign in, sign up. And you'll notice that what actually happened was we switched over to a web view that's showing our login. This login is actually provided by Azure B2C, but depending on your OAuth provider, whether you're using something like Okta, AWS Cognito, that sort of thing, we can basically just hook that up with a couple of settings. The reason that we use a third-party provider rather than doing this ourselves is that we're getting a lot of security that we don't have to implement in our application. So a homegrown application is going to give you, or homegrown authentication, you're going to have to deal with a whole bunch of different factors. So doing this with a product like AuthConnect is going to eliminate those sort of factors. And we'll talk about that in a moment. And the first one is that web view that we switched over to. So this web view that we're looking at the moment that's providing this login is essentially controlled. This is by Azure, so that username and password that's associated with this login is provided by them. It never touches our application, so we don't deal with usernames and passwords. And essentially all we need to deal with is tokens. So that's one big load off us with dealing with those. Now, with an OIDC provider, they will also give you ability to customize the look and feel of this login. So you'll probably work with your designer to improve this look and feel, put your own branding on it, choose the type of login that you may want to use. Maybe you've got a social login that signs in with Apple. Maybe you've got multi-factor authentication that you'll add in. That's something that's provided by that OIDC provider. You can also customize something like the domain that sits at the top here. Now, the main reason for effectively using a domain, a separate domain and a separate web view here is that the web view that is provided in your application isn't as sandboxed as a web view that's provided by Apple or Google. The web view that's showing here is actually called an AS Web Authentication Session for Apple, and on Google, it is Chrome Custom Tabs. These are specific web views that are provided by Apple and Google that are designed with auth in mind. They're sandboxed so that things like cross-site scripting attacks, injection attacks where we're capturing events and other things can't happen with that web view. We've got a good sandbox that is going to essentially protect anything that goes on within this web view. And that's something that you would need to deal with if you were managing a homegrown solution. So let's have a look at that sign-in. So in my example here, I've pressed into the username and password field, and it's brought up the password manager that's built into my Apple device. So maybe I'm using Apple's built-in password manager. Maybe I'm using 1Password. That is something that's built into these web views by Apple or Google so that you don't have to implement that yourself. So I'll sign in here. And for this, we've got a biometric login, and it's past that and redirected back to the application. And so what's actually happened here is our Azure B2C provider that we've used has redirected back to our app, and it's passed the token along with it. So essentially in our application, we're now using the access token and refresh token that have been provided, and we're using it in the app. So with AuthConnect, we've got a login that's working. We've got a token that we've got access to. And in one of my pages here, I'm actually using some information from that token, which includes claims like my name, the unique ID that's associated with that token as well. That doesn't change over time. And then I can also use something like a role, like am I an admin user? Maybe I've got additional access into this application. And then if I want to sign out of the application or exit out of the application, we can have a look at how we might have used Identity Vault. And we'll talk about that in just a moment. So let's quickly run through how we actually set up Auth Connect and explain what exactly is going on there. So first up, let's go down to code. The first part of the application that I'm looking at, and this is an Angular application, but we can basically do this with React, Vue, or just vanilla JavaScript. We've imported a few things from Auth Connect. So this is just a regular plugin that we install, npm install Auth Connect. And then we've got essentially a class that we've got here that we'll call whenever we need to sign into the application, sign out of the application, check whether we're authenticated. In here, I've just got a simple init function, and this is where I first set up the application, set up Auth Connect. Here we're actually enabling web as well. So this application can run on web, and Auth Connect can work on web as well, going through that similar auth flow. So it works the same, effectively the same way, whether you're using iOS, Android, or web. I've got a few things to customize bits of the look and feel. I've got some coloring that I'm using. I can switch that out to my branding colors for the Chrome that appears around the web view. I can choose things like whether it's animated or not. On web, I've got here an additional security mechanism called Pixie that I've added in as well. And I've also got a UI mode set. This one effectively means that I can reuse the current web view to open up the page and then redirect back to the same page without having to open up a pop-up window. So a few things on setup here. You can leave a lot of these blank to go with the defaults as well. Okay, so past getting Auth Connect set up, we've got a login method, and we can see here we're just calling Auth Connect login. We're using a provider, and we provide a top list of providers that are automatically configured. You can also connect to your own OIDC provider to this, or use a generic provider as well. That'll work with any sort of OIDC compliant auth provider. We've also got some auth options, and this is the things that are unique to our instance of auth provider. So in this example, I've got a client ID associated with the application. I've got a discovery URL that's associated with the app. And this is just the backend setup that is required for the application to function. The other thing that we need to make sure of is we've got a redirect URI so that when we log in, it knows where we're going to redirect back into the application, and it'll pass that token back to us. So that's effectively the setup that's required to do a login, to make sure we've got configuration correct, and go from there. You'll see also that we've got a logout method. And again, we've got logout with our provider that we used from before. And this has also got the auth result. I'll talk about that in a moment, but that's basically where the token resides. You'll also notice that in that configuration, I didn't actually have anything that was publicly accessible. So there's no client secrets. Everything is publicly available in the application. And essentially the security that comes out of that is the redirecting out with our client ID and redirecting back to the application that is expected to run and grab that token. The next thing that you'll need in your app is some sort of is authenticated method. And that's the thing that whenever we route to a particular page, maybe that page you can only access if you're logged in, So we want to call that is authenticated method and make sure that we're the right person. And this is a method you can just copy the example from. It's in the docs as well. But what it essentially does is it does a check on our token. And here we're using an auth result. We'll talk about this get method in the moment. If you weren't using something like Identity Vault to store the token, maybe you just put that in memory and store that. And we'll see what the ramifications of that are a little later. But essentially, we're checking to see whether the token's expired. If it is expired, we want to refresh that token. And so what that's effectively doing is it's calling our OADC provider. It's returning an updated token with a new expiry date, and we can use that token during its lifetime. Usually you'll want to have short-lived tokens that get refreshed often. That way, if that token gets accessed by anyone, it can only be used for the lifetime of that token. There's no way for it to be easily refreshed without that. Every token that we're talking about here is essentially got a lot of public information, including the claims of the token, but it's also got a little thing at the bottom of it with a signature that is a signed representation of the token to make sure that effectively that token can't be forged. And so we want to make sure that when we get that token, it is essentially secured in the application. So past refreshing that token and saving that, that is authenticated method is going to be used in our app to effectively use or do a check. And where we do those checks are usually done through something called an auth card. An auth card in this example, I've got my routing module here. Bring that up. Essentially, this is any route that my app may go to. If I'm going to the sponsors tab, if I'm going to the profile page, going to the swag module in our app, we've got an auth guard service that's going to check to see whether that user is logged in or not before actually going to that page. You'll notice that on our login page and maybe our auth transition page that we don't have that auth guard because that can be accessed by a guest. We look at an auth guard, essentially this is just a method that it's calling that is authenticated method. If it fails for any reason, then essentially we're going to be clearing the data out and returning back to the login. So that's one place where we need to effectively check our tokens to make sure we can use them effectively, is routing to pages. Another one is when we're making API calls as well, and you'll include that in when we're calling the back end. So those are the pieces to effectively get Auth Connect hooked up to our application. Now, obviously, once we've got that token, we need to store it somewhere because whenever we go back into that application, we want to be able to not have to force the user to log in again. So if I have a look at my app right now and I exit out to the page, say I've left my app for a little while, someone has taken my phone, noticed that it's unlocked at the moment, and they want to get into my application. Maybe you've got a banking application and you want to verify that they're the person that's allowed access to that app. So when I resume the application, you notice that it's brought up the biometric prompt again, and that's something that's provided by Identity Vault. Essentially what that's doing is verifying whether the user has access to that token and storing that token as well. So I have to pass that prompt before it gives me access into the app. If I don't pass that, it's going to return me back to the login and clear the vault as well. So that means if that was someone who wasn't supposed to be using our app, and they now have access to my device, they no longer have access to the token that's associated with that. So that means if they don't have access to the token, they can't use that for things like replay attacks, for accessing the API from scripting, that sort of thing. So let's have a look at how you actually used Identity Vault in this case to store that. For that, again, we've got another Vault service, and in this one, I've used Identity Vault, imported that in. And with that, I need to obviously set up the Vault. So what does the Vault actually do? So what it actually does is it's a basically key value storage for secure encrypted data. So that can include things like a token, but maybe it include an API key or a key to storing data. So I can have one or more vaults that store this information. And for this example, I've got my auth token. I've got a key that's associated with that. And here I've said that I'm going to be using device security, and I'm going to be using biometrics for that. Now, maybe my application, I'm not too worried about the access token. And if a user is basically just using their device as normal and wants to just return back to the application, doesn't want to do the biometric prompt, I can change that out. I can change that vault type to say secure storage, and change the device security type to none. And then it's essentially going to encrypt that using what was used to access the device. So maybe that device has a fingerprint lock to unlock the device. Maybe they've got a PIN code that they've got to enter. Effectively, it's using that to secure the token, store it on the device in the secure enclave of the device, and make sure it's well encrypted. Now, this is something where if you're using, say, a free third-party tool, third-party plugin, you may be doing showing a biometric prompt, but you're only using that to sort of show the biometric prompt and not actually secure the data that you want to secure. And that's a common mistake that people make as well. They may use that to effectively present that there's biometrics in their app, but they're not actually securing anything on the back end of the device. So first up, we set up the configuration. And in here, after we've set up the configuration, we've got an init method that we'll use. And this one, again, works on web. We're using a browser vault so that we generally use that for testing. Testing is a lot easier than on device, and hooking up a device to your machine, making sure that everything is up and running. So we can also test this on web as well. And there's a browser vault that essentially emulates what Identity Vault on native will do. We're also doing a couple of checks here. Maybe the device doesn't have biometrics at all. Maybe they've turned that off. In that case, I'm using an alternative vault. And this is where I've got a backup plan. If they don't use biometrics, I'm going to use secure storage and store the token that way. I've got a few events that I've stored. I'm just logging those out. And then I've also made this additional call here where we're hiding the screen on background. So say, for example, you're using a banking application and your bank shows your bank balance on there, or maybe it shows your date of birth on that particular screen. We want to be able to hide that screen as soon as you exit out of the application, because the app switcher that you can switch between apps may show a screenshot of that. So we also hide that screen on background as well. Then we also use a couple of methods, clearing the vault and setting values. And this is where we store the AuthConnect token in our vault. And it's as simple as calling set value. And then whenever we need to access that auth token, we can just call get value on there as well. So again, it's a key value store that can store stuff encrypted. So that's essentially it for AuthConnect and Identity Vault and where we might use those two in that scenario. Now, another thing that you'll want to do in your application is you may want to store additional large amounts of data. And for that, we might use our secure storage product. That's, again, a plugin that we can install in the application. I've used it here for a particular sort of scenario. For this one, I'm using it with an offline sort of pattern. I want my conference application to work while I'm disconnected from the network, because maybe at the conference, when they're in the hallways, they don't have Wi-Fi connectivity. We want them to be able to access things like the agenda of the application of the conference, to be able to access speaker lists, to be able to get notifications when a talk happens, that sort of thing. But we also want to, if they set up personal reminders, things like that, we want to store that information securely as well. So we can use the secure storage feature of the plugin to store additional information. And I'll show you the pattern that we're using in the application. So for example, if I were to turn on Wi-Fi access, turn on airplane mode and navigate around the application, we've still got access to all the calls that our app is making back to the API. That is still functional. And we do this with a little change of pattern of how we access the API. So in a normal app, I'm going to have something like an API service. And in here, we do things like getting data from the API. Maybe it's for speakers, agenda, sponsors, company information, whatever the backend API is providing. In here, I may make a call out to, say, fetch. Maybe if I'm using Angular, I'm using HTTP client. If I'm using React, maybe I'm using Axios, that sort of a thing. That API call that I'm using, obviously here, just got to comment it out at the moment, but I'd also make sure that I'm passing that token back to the backend API and getting the result back. Once I get that result back, what I want to do is I want to store that information. So in this pattern, what I'm doing is doing a get call to the URL. I'm getting the data back. And in here, I'm using secure storage to essentially store a key value pair where the key is a URL and the data is the response back. Whenever I get data from the API, it's going to do this little check here. It's going to get a value out of secure storage. If there was a value in secure storage, then it's going to return that information. If there is no data, then I'm going to get it fresh from the API. That way, it's going to cache that information, and if I'm offline, it's going to return that information. If I've got slow Wi-Fi, it's going to return that as well. So this is a sort of a use case that I can do with secure storage. Secure storage has a couple of different APIs that I can use. One is a simple key value store. And this is what I'm using to store large amounts of information, including those API results that came back from the application. Now, obviously, I need to store that information. When I store that onto the device, this is where I'm also effectively using the Identity Vault to store information. because whenever I create a secure store on the device, I need some way to encrypt it. With secure storage, there's a key that's associated with that. To get that key, I'm again using Identity Vault. Here I'm generating a unique ID, storing that in a vault that's using secure storage. And that's the key that will unlock data that's stored in our key value store of data and information. Now, with more complex use patterns, maybe you want to store a whole database on the back end and have a whole SQLite database on the front end and sync between those two. Secure storage also does SQLite, so you can do basically SQL patterns. So maybe it's select star from speakers where speaker ID equals this, or maybe it's something relevant to your data. So that's where we've used our application. We've effectively stored all of the information that we want to have offline, and essentially working a lot quicker than if we had to make API calls to the back end. We're running the app offline using a secure storage. We're storing it on the device with a key that's been encrypted using Identity Vault. We're storing our tokens securely as well. And that effectively eliminates a lot of issues that are effectively the OWASP top 10. So that pretty much concludes out the demo of the application. This is where we can probably give you guys some time to ask some questions. I see we've got some there already.
All righty, the last slide here. Events are just going to keep on rolling here at Ionic. We do have our next webinar scheduled. It is for May 3rd, and this one will be with Manfred Steyer. For any of those of you who attended our Micro Front-End Summit, he was a guest speaker, and he's coming back to collaborate with us again. So this presentation will be on May 3rd, 12 p.m. Central, and so that was the same time frame as today's webinar on Make Module Federation Work. I'm going to go ahead and link the webinar registration page for you to take a look, see if that's of interest, and if it is, then we look forward to seeing you on May 3rd. So huge shout out to Connor and Damian, and huge shout out to you. Thank you for joining us live today.
Thanks so much, everybody. And thank you, Damian, for the great demo.
Thanks all.
Take care, everybody.